Let's look at 5.2, completing the square. We always want complete things, so this is right up our alley. Expand the following expression. First off, I'm going to tell us that if you write that x plus 4 quantity squared is x squared plus 4 squared, I will throw something. That is not the case. X plus 4 squared means x plus 4 times x plus 4. Are the x squared and the 4 squared going to be in there? Yeah, but we're missing stuff. So here we can do our double distribution. X times x is x squared, x times 4 is 4x. And 4 times x is another 4x, and 4 times 4 is 16. We add up our like terms, and only our like terms. On our last test, we added things that weren't like terms. So we get x squared plus 8x plus 16. And that is the product of x plus 4 and x plus 4. There we go. So number 2, now we have to factor. We're going the opposite direction. So first step always to look for a GCF. Well, the coefficient of x squared is 1. So nothing goes into 1, 12, and 36 besides 1. 36 doesn't have an x, so there is no GCF. So we do our diamond problem. 36 is our product, 12 is our sum. So our two numbers in question are 6 and 6. Now, can we skip right to here now that I have my diamond problem answers? Yes, because of this 1 in front of the x squared. So they're both positive 6's. And of course, in front of it will go our x's. So that, or, and this is what we're going to see today, x plus 6 squared. So if I ask that question, either answer would be fine. Just realize that x plus 6 squared is the same thing as x plus 6 times x plus 6. All right, now we have Hannah and Enrique are using different methods to solve the same equation. X squared minus 6x plus 9 equals 16. Well, Hannah first got it set equal to 0. There was no GCF. We did a diamond problem. Negative 7 is our product, negative 6 is our sum. So it's negative 7 and 1. And you're going to know coefficient of x squared is 1, so we could just skip right to x minus 7 and x plus 1 equals 0. Then from there, you set each one of those equal to 0. Because we have something times something equals 0, well then one of those somethings has to be 0. So x minus 7 equals 0, you add 7 to both sides, x equals 7. X plus 1 equals 0, subtract 1 from both sides, x equals negative 1. So we got 7 and negative 1. Enrique wants to do it a different way. So he factors x squared minus 6x plus 9. We did our diamond problem. Product of 9, sum of negative 6. So that would be negative 3 and negative 3. It's the same number. So when we factor it, it's really x minus 3 times x minus 3. But we rewrote it to be x minus 3 squared. And of course it equals 16. We haven't done anything with the other side. Now, square root them up. So we get, kind of skip that step, x minus 3, because the squared and the square root cancel out, equals, well, the square root of 16 is 4, and it's plus or minus 4. Because negative 4 times negative 4 is also 16. Of course, that's what it says here. So now x minus 3 equals 4, and x minus 3 equals negative 4 are our two equations because of the plus or minus. So we get an x value of 7 and an x value of negative 1, same solutions that Hannah got. So let's take a look at these. Does Hannah's method work? If her method is valid, explain the reasoning she used. If her method is not valid, explain why not. So we factored it, put it in just factors. The factors are equal to 0, so one of those factors has to be 0, or both of them. So that's what we're using there. Does Enrique's method work? If it's valid, explain the reasoning he used. If this method is not valid, explain why not. So he kind of put our x's kind of together when he factored, so that there were really just one x term. It was going to be squared with a 2 out there, but it's just one x term. Then we took the square root. We know that we can take the square root to get rid of a squared on any kind of equation. So quite honestly, I'm not sure why he would have done that method, but it works. can use either Hannah's or Enrique's method to solve the equation x squared plus 10x plus 25 equals 3. Well, if we use Enrique's method, we have to factor x squared plus 10x plus 25, which is x plus 5 squared, equals 3. We square root them, so x plus 5 equals plus or minus root 3. Subtract 5, we have negative 5 plus or minus root 3. So, of course, Enrique's method works. Now does Hannah's. So x squared plus 10x, we're going to subtract 3 from both sides to set it equal to 0. So 25 minus 3 is 22. We do our GCF, but there isn't one. Our coefficient of x squared is 1, and 22 doesn't have an x. So we do our diamond problem. 22 is our product, 10 is our sum. So what two numbers multiply to 22 but add up to 10? The only numbers I know that multiply to 22 are 11 and 2, which gives us 13, not 10, or, well, 22 and 1. That obviously doesn't give us 10. So we can't do Hannah's method because our answers are irrational. We have the square root of 3. It's not an integer. They're not whole numbers. We can only factor when our solutions are rational, either a fraction or a mixed number or several other things. So make sure that you're just following the steps of what you know how or what you know to do. Use square roots to solve quadratic equations. What are the solutions of 25 equals x squared plus 14x plus 49? So this is what Enrique did. So that's what we're looking at today. So we solved the quadratic equation by finding the square root of both sides. You can use a similar method to solve more complicated quadratic equations. So again, x squared plus 14x plus 49, product of 49, sum 14. Two numbers have to be 7 and 7. Or x plus 7 squared. When we do these, this should factor into a perfect square. And it did here, x plus 7 squared. Then we take the square root, because we want to get rid of that squared. And we have plus or minus 5 equals x plus 7. So we split that up into two equations. Positive 5 equals x plus 7. Negative 5 equals x plus 7. Subtract 7 from both sides of both equations. And we get negative 2 and negative 12 as solutions. Because these were integers, we also could have factored this. But we didn't have to. So find the solutions to the equations. So 81 equals, now I know I can factor x squared plus 12x plus 36. It turns out to be x plus 6 times x plus 6, or x plus 6 squared. Now with the squared, we get rid of it by square rooting. So square root of 81 is plus or minus 9 equals x plus 6. And of course our last step to solve is we subtract 6. So we have negative 6 plus or minus 9 equals x. And you can put the 9 first, just make sure you have the plus or minus in front of that. So negative 6 minus 9 is one equation, and negative 6 plus 9 is one equation. So we get negative 15 over on the first side, and we get positive 3 on the second side. So those are our two zeros. Not too bad. Letter B, same type of thing. 9 equals, can we find two numbers that multiply to 64 and add up to negative 16? Yeah, negative 8 and negative 8. So x minus 8 squared again, because it's x minus 8 times x minus 8. And now we can take our square roots. Square root of 9 is plus or minus 3. Square root of x minus 8 squared is just x minus 8. And then we add 8 to both sides. So just like in the last problem. So we got 8 plus or minus 3 equals x. So one of them is 8 plus 3 equals x, or 11. And one is 8 minus 3 equals x. And of course that's 5. So we got our two solutions using our square roots. All right, now we're going to look at the process of completing the square. kind of like what we were doing, a little bit different though. How can we completely square to write an expression as a perfect square? So we want to turn x squared plus bx into the form x plus p squared. Really just what we were doing. Not every quadratic expression is a perfect square trinomial. We saw that with the other ones, but it's not always going to be the case. The model below depicts the process of completing the square. So we have x squared, of course that's x times x, and bx, b times x. We can cut that b in half, just right down the middle. Put half to the right of our x squared, half to the bottom, and then we're just missing this little piece to make a perfect square. Well, this is b over 2. So here, the area would be b over 2 squared. If you don't understand this diagram, don't worry, we can still do these problems fine. So to create a perfect square trinomial, add b over 2 squared to the variable expression, to both sides. So it shouldn't be too bad. So I'm going to write it a little bit differently than they wrote it in a book. So x squared plus 8x plus 5 equals 0 in the form x plus p squared equals q. So we don't even need the answer yet. We just need to get it to the form where we can solve it. So we want to kick the constant, that 5, to the other side of the equation. Now we're going to add something in to both sides. Come on. We're going to add it at the end of x squared plus 8x, and we have to add it to the other side of the equal sign as well. So what are we adding? Well, we're adding 8, or b divided by 2, 4, and then square it. So we're adding in 16. Now, when we factor it, we want two numbers multiplied by 16, add up to 8, it's got to be 4 and 4. So it's x plus 4 squared equals negative 5 plus 16 is 11. So it can be written like that. Can we go further? Of course, just like we were doing on the problems above. But they weren't asking for that in this situation. Another kind of shortcut, I guess, or thought, this number inside the parentheses, now of course not the x, but the constant, is always going to be the same as b over 2. And that's, well, that's exactly what it said. Or it's over here, I suppose. So we just use the same process over and over and over again. So how can you write the equation x squared minus 6x minus 11 equals 0 in the form x minus p squared equals q? Well, I'm going to, and we have the steps below, so move the constant to the right side of the equation. So x squared minus 6x plus something equals, well, we add 11 to both sides, so it's a positive 11 plus something. So add b over 2 squared to both sides. Our b is negative 6. And negative 6 divided by 2 is negative 3. Negative 3 squared is our positive 9, so that's what we're adding in. When we factor this left side, it is a perfect square. Two numbers that multiply to 9 and add up to negative 6 would be minus 3 and minus 3. 11 plus 9 is 20. And that's all they're looking for. They just want us in that form. So again, these are the steps. So if you get lost, look here. Move the constant to the right side, add b over 2 squared, factor the expression, take the square root of both sides, and solve for x. Just what we've been doing. So we are going to solve 0 equals x squared minus 2x plus 3 by completing the square. Well, again, step 1 is to kick the constant, the c value, to the other side. The way we do that is we subtract 3. Now it's going to be x squared minus 2x plus something equals negative 3 plus something. So we cut our b in half. Negative 2 divided by negative, or negative 2 divided by 2 is negative 1. And then negative 1 squared is 1, and that's what we're adding in. So when we factor the left side here, what numbers multiply to 1 but add up to negative 2? Well, that would be negative 1 and negative 1. So x minus 1 squared. Negative 3 plus 2 gives us our negative 2. So now we're here. So we take the square root. Square root of negative 2 will be plus or minus. The negative comes out as an I, so you poke out your I. And we still have the 2 inside the radical because it's not a perfect square. It doesn't have a pair. And square root of x minus 1 squared. Square root and the squared cancel out. So plus or minus I root 2 equals x minus 1. Add 1 to both sides. And we have our solutions. 1 plus or minus I root 2 equals x. You can write them separately, or you can write them together. I'll probably write them together because I'm lazy. So that's what we're doing. Same steps over and over and over again. So solve the following equations by completing the square. I'm going to kick the 8 to the other side, so it's negative 8 plus something equals x squared plus 4x plus something. We got to find what to add in there. So we take our b, 4, divide by 2, 2, square 2, 4. So we're adding in 4 to both sides. On the left, negative 8 plus 4, of course, is negative 4. X squared plus 4x plus 4, if we factor that, we want two numbers to multiply to 4 and add up to 4. Well, it has to be 2 and 2. So it is x plus 2 squared. Or we have the 2 right here. That's what goes inside the parentheses. So whatever way works, go for it. Now we want to keep going. We don't solve it. So we square root because we have the squared thing isolated. So squared and square root cancels out, the whole idea. So we get x plus 2. Square root of negative 4. Well, we can take the square root of 4. Square root of 4, of course, is 2. Now we still have the negative 1 inside the radical. But hopefully remember that the square root of negative 1 is really I. So the square root of negative 4 is 2i. Oops, plus or minus 2i. Do not forget that. And then our last step is to subtract 2. So at the end, x equals negative 2 plus or minus 2i. Can you write it as plus or minus 2i minus 2? Of course. Addition and subtraction are commutative, so you can move them around. Letter B here, same thing. We're going to kick the 17 to the other side by subtracting it. So we have negative 17 plus something equals x squared minus 8x plus something. So we take our b, negative 8, cut it in half, negative 4 squared, positive 16. That's what we're adding in here. So negative 17 plus 16 is negative 1. What two numbers multiply to 16 and add up to negative 8? Well, that would be negative 4 and negative 4. So x minus 4 squared. We square root them up. On the left, the square root and the squared cancel out. We get x minus 4. On the left, we get square root of negative 1. I wish we knew what that was. Ah, we do know what that is. That's I. So we got plus or minus I over here. And of course, our last step is to get rid of that minus 4. So we add 4. So 4 plus or minus I equals x. And you could write it plus or minus I plus 4. It doesn't make a difference. All right, so let's just keep on going. We got two more problems here. X squared minus 4x minus 45. So x squared, oops, minus 4x. I don't want to add there. And I'm going to kick the 45 to the other side. So I'm going to leave a space for what I add in equals positive 45 plus whatever I'm adding in. Negative 4 divided by 2, negative 2. Negative 2 squared, 4. So that's what I'm adding in here. On the right side, 45 plus 4 is 49. On the left side, what two numbers multiply to 4 but add up to negative 4? Well, that'd be negative 2 and negative 2, or x minus 2 squared. Then we square root them up. x minus 2 equals plus or minus 7. We add 2 to both sides. So we get x equals 2 plus or minus 7. Now, we can solve this because we can do 2 plus 7 and 2 minus 7. So here's our positive, here's our negative. So that would be 9, and this would be negative 5. So not different than what we were just doing above. But we got nice numbers this time. We didn't get I, we didn't get irrational numbers, square root of something, not a perfect square. We actually had a perfect square here, so that's nice. Letter D, same thing. X squared minus 2x. We're going to kick the 37 to the other side, so we add 37 to both sides. And we leave the spaces on each side for whatever we're adding in. So that's negative 2 divided by 2, cutting it in half, so negative 1. And negative 1 squared is 1. So we're adding 1 into these equations. So when we factor x squared minus 2x plus 1, we want two numbers, then multiply 1 and add up to negative 2, so that would be negative 1 and negative 1, or x minus 1 squared, equals 38. Then we'll square root them up. X minus 1 equals plus or minus square root of 38. Can we factor the square root of 38? Well, let's see. I know it's even, so I can take out a 2, and I'm left with 19. 19's prime, 2's prime, can't go any farther. That's it with that. You can't simplify the square root of 38. Now we just add 1, and x equals 1 plus or minus square root of 38. You can write them separately, but I prefer to write them together. Alright, now we have a word problem. I'm going to complete the square to solve a real world problem, because that's what life is. So Libby plans to create a rectangular pasteurizing enclosure. Don't know what that is, but doesn't matter. She has 340 meters of fencing available for the enclosure's perimeter and wants to have an area of 6,000 meters squared. What dimension should Libby use? So, if I can scroll down, which I can't, there we go. So let L and W represent the length and the width of the enclosure. So our perimeter is always 2 times the length plus 2 times the width equals 340. So we add up the four sides. L plus W plus W. And then we can divide by 2 and simplify the equation a little bit. So actually what they did first was subtract 2L and then divide by 2 so they solve it for W. You could do the same thing and solve it for L as well. So 2L equals negative 2W plus 340. Divide by 2 and L equals negative W plus 170. The same type of equation that they got over here. So that's our perimeter stuff. So we're going to look at this from 2 points of view. One is the perimeter, and one is the area. Our area is down below. So the area, she wants to be 6,000 meters squared. So length times width has to be 6,000. Well, if you notice, and they kind of snuck it in here, they're going to substitute in 170 minus L for W. And that's what they did. So 6,000 equals L times 170 minus L. Then we can distribute the L, so we get 6,000 equals 170L minus L squared. And we don't really want a negative L squared. Having the leading coefficient be negative is not very nice. So we basically flipped this whole thing around. We added L squared to both sides, and we subtracted 170L from both sides, and we subtracted 6,000 by 2 sides. So we just switched everything so the signs just went the opposite. So we're sitting at L squared minus 170L plus something equals negative 6,000 plus something. So of course it's negative 170 divided by 2. Use my calculator just to make sure. So it's probably good if you have a calculator to use it. Negative 85, a much bigger number than what we're used to. I'm not squaring that in my head. I'm good, but I'm not that good. And we got 7225. So that's what we're adding in. So here is probably a good time where we realize that this number when we got when we cut it in half, that's going to be in our parentheses when we have our perfect square trinomial. So L minus 85 squared, because 85 or negative 85 times negative 85 is positive 7,225. Negative 85 plus negative 85 is negative 170L, or negative 170, I suppose. We simplify the other side as well, negative 6,000 plus 7,225, and we get 1,225. So we square root it. The square root and the square cancel out on the left, so we have L minus 85. Square root of 1,225 is a perfect square, which is nice, so it's 35. And we always have the positive and negative version. So it's 85 plus or minus 35. 85 plus 35 is 120. And 85 minus 35 gives us our 50. So we didn't really answer the question yet. What dimension should Libby use? Well, we have our length, 2 lengths actually. So we substitute those back into the original equation, or equations, so that we can find our width. So when L is 120, then W equals 120 minus L, or 170 minus L, which is our 120. And of course that's 50. And when L is 50, 170 minus 50 is 120. So really they're the same dimensions. Either one is, or the length is 120 and the width is 50, or the width is 120 and the length is 50. So Libby should make 2 sides of the enclosure 120 and the other 2 sides 50 meters long. And of course, we can always check our answers, and that's what we were doing here. So again, just completing the square, stuff we know how to do, nothing different. All right, we're just going to summarize this lesson up and be done with it. Again, we're talking about completing the square. So the rectangles show x squared plus 10x are arranged into a square. So we have x squared, and we have 10x, 10 across, x down, but then we cut it in half, just like we're doing when we actually do with the algebra. So we cut it in half, and we put 5x to the right of it, 5x above it. But we need to find the area of this little guy. What's missing? Well, we're missing a 25. Each of those sides is 5. So 25 would complete the square. Now, do you really need to know that? Not necessarily, but that's where it's coming from. What we need to know is this algebraic model. Solve x squared plus 10x equals 3. And I'm going to write a little bit differently. Plus something equals 3 plus something. 10 divided by 2 is 5. 5 squared, 25. So that's what we're adding in. We factor the left side, and it's x plus 5 times x plus 5, or x plus 5 squared, equals 22. Oh, for those of you who are actually keeping score at home, that's not 22, that's actually 28. Then we square root them up, and the square root of 28 can be simplified into 4 and 7, and then of course 4 is 2 and 2. Don't know what happened there. So we got a pair of 2's we can bring out, but the 7 stays inside the radical. That's how we got here, and of course it's plus or minus. Then we subtract 5 to get x by itself, so negative 5 plus or minus 2 root 7 is our solution. They're real solutions, but they're irrational because root 7 isn't an integer, it's not a perfect square. So that's how we do completing the square. We add something in to make it x plus something squared.